Okay, we back to our last subtopic 4.4, which is roots and zeros of the polynomials. Okay, wait a minute, I open first. Okay, so in this subtopic we will cover how to find roots and the zeros of the polynomial and determine complex zeros of the polynomial up to 3 degree. Okay, so we look at the definition first. So what is the definition of zero? Okay, zero of a polynomial px is a number a, okay, such that pa equals to 0. X equals to a is called a root of the polynomial equation px equals to 0. So if we refer to the previous subtopic, factor theorem just now, okay, factor theorem, if you divide your px with a linear x minus a, and when you substitute pa equals to 0, you get 0, meaning that x minus a is the factor of your polynomial px. Okay, in other words, this a is the 0 of the polynomial px. And when you write as x equals to a, then this expression is we call as the root of the polynomial equation px equals to 0. It's just the same, it's just related. Okay, so in general, if x equals to a is a root of the polynomial equation px equals to 0, then x minus a is a factor of pa, or if x minus a is a factor of px, then x equals to a is the root. Okay, so every polynomial equation of degree n has exactly n roots. Some of these roots may be repeated. So for example, if you have fx equals to ax squared plus bx plus c, okay, ax squared plus bx plus c, okay, so basically this is the highest degree in this polynomial, which is 2. So since n equals to 2, okay, so since n equals to 2, then you might have maximum of 2 roots in the polynomial. Okay, and then some of these roots may be repeated as well. For example, if you have a cubic function, so the roots might be repeated. You might have same number of roots. Okay, so we look at this example. Show that negative 4 is a 0 of this polynomial. So now you have px equals to 6x cubed plus 23x squared minus 5x minus 4. Okay, so you want to prove this negative 4 is a 0. So we substitute p negative 4 inside your polynomial, then you should have 0 here. Okay, should be no remainder. Alright, macam begini ya, p negative 4, then you substitute everything, then you get 0. So we conclude that since p negative 4 equals to 0, then negative 4 is a 0 of px. In other words, we can write x equals to negative 4 is a root of px. Okay, see how they write? If 0, you just write the value. If root, you must write x equals to. Okay, next example. Factorize px equals to 2x cubed minus 9x squared plus 3x plus 4 and write all the zeros. Okay, since they didn't give you any condition here, so you must check by try and error. Okay, you must substitute any value x here and you must get 0. So how we choose a number? You look at the constant term. You take out factor of 4. Okay, what is the factor of 4? Plus minus 1, plus minus 2, and plus minus 4. So you try this 6 number inside here, inside your px. So you try p1, what you get? P negative 1, what you get? p2, p negative 2, okay, and then p4 and p negative 4. Alright, so which is the value here give you 0, then we can say that it is a factor. Okay, by try and error here you find that when you substitute x equals to 1, then you get 0. So we can say x minus 1 is a factor of your px. Okay, x minus 1 is a factor of your px. So from your polynomial, you can factor out x minus 1 and you left another bracket here. Okay, your px is a polynomial of degree 3. You already take out a linear factor, one bracket here, so meaning that you left another quadratic equation in this bracket. So ax squared plus bx plus c. So you must find this a, b and c. Okay, so how we find this a, b, c? First method, you use long division. Okay, your polynomial px. Okay, this is your px and this is your dx just now, right? Your divisor, and then you have no remainder. Okay, then you found this quotient. Okay, quotient 2x squared minus 7x minus 4. So you get the factor 1 of after you take out x minus 1, then you get this. After that, you must factorize this quadratic equation because the question is asking you to factorize completely. Completely meaning that kena factor sampai habis, sampai tidak boleh factor lagi. Okay, after you get this all these three factor, since you have 3 power 3, definitely you have 3 bracket. Alright, so now you take out the zeros. So how we write? The zeros are ini 1, negative 1 over 2 and 4. Okay, sedangkan ataupun you gunakan by comparison. Contoh, kita tengok contoh lain by this one. Same question, same method. Find the roots for the equation of x cubed plus 3x squared plus x minus 1. So in order to find the value, we use try and error method first. Tapi kita tengok yang constant term punya factor, then we check plus 1 and minus 1. Okay, so in this case, when they substitute x equals to 1, it's not equals to 0, so we reject this value. When you substitute x equals to negative 1, then you get 0. So we can say that x plus 1 is one of the factor. Power 3 here, meaning that you left another quadratic equation. So you use long division to get this. Okay, to get this. Because your polynomial is x cubed plus 3x squared plus x minus 1. So when you factor out x plus 1, ini, we want to find this equation here. Okay, the product is the addition of the two polynomials. Since here is 3, here is 1, meaning that you left another quadratic 2 here. Okay, ataupun, okay, we finish this method first. X plus 1, x squared plus 2x minus 1, then you found out yang ini tidak boleh di-factorize anymore. Tapi when you check dia punya b square minus 4ac, nature of the roots, they will give you a positive value, meaning that kita mesti akan ada roots. So we use formula, last week formula, negative b plus minus z, b square minus 4ac over 2. Okay, and then you get one root here, two roots here, plus minus, meaning that there are two answers here. Okay, same thing with this one, you can try. Okay, you check, you substitute with factor of 6. So you can try plus minus 1, plus minus 2, plus minus 3, and plus minus 6. Okay, you might use calculator as well to shorten your try and error method. Also can, boleh, no problem. But then in exam, kena tunjuk a few method, a few answer lah yang tidak dapat kosong. Maksudnya kamu tunjukkan effort untuk menjawab tu. Even though saya tahu kamu mesti pakai calculator. Okay, P1 kena tunjukkan sama ada dia kosong ataupun tidak. Depends lah, check. Okay, and then by inspection ini maksudnya by try and error lah. Try and error. So they found that P1 equals to 0 and P negative 1 equals to 0 as well. So daripada sini 1 is x minus 1, negative 1 is x plus 1. These two are factors. Okay, your Px is power 4. Okay, and then ini kamu sudah found two factor, x minus 1 and x plus 1. Power 4 ini sudah keluar satu power, then you left another quadratic kan di sini, x square plus bx plus c. So how to find ini? Either you expand this three bracket and compare the coefficient ataupun you do long division. Okay. In this solution diorang buat comparison. Okay, after you do comparison, then you find the value of a, b, c. You akan dapat this quadratic equation. Then tengok quadratic equation ni sama ada boleh di factorize lagi. Kalau boleh factorize, kalau tidak boleh then just find using formula. X equals to negative b plus minus b square minus 4ac over 2a. Okay, then settle. Then you get the roots. Okay. So this one you must take note when attempting to factorize a polynomial of degree 4. It is necessary to find two linear factors using the factor theorem. Macam begini kan, in this case they find two. Dia buktikan ada dua factor yang dia jumpa, then easily. Because after you take out two bracket ini, you left only a quadratic, so senang. Ataupun you already found one, okay, and then you take out satu bracket, then you left a cubic function. So you find that cubic function first, then you repeat this step. Again, try and error, baru dapat yang ini. Either one lah, you choose which one is easy for you. Okay, the last one. Complex zeros of a polynomial when you have I. So if a plus bi is a zero of px, then conjugate a minus bi is also a zero of px. This complex zero of a polynomial with the real coefficient occur in the conjugate pairs. So if complex zero, diorang akan wujud bersama-sama dengan syarat coefficient polynomial kamu itu must be an integer. Okay, maksudnya yang ini, contoh example ini, nombor di sini mestilah integer. Tak kisahlah dia positif ke negatif, yang penting mesti integer. Kalau dia fraction, maksudnya syarat ini tidak applicable. Okay, so since yang ini 2, negative 5, negative 2, 15 adalah integer, maksudnya kalau diberikan satu roots dia adalah 2 minus I, if one roots adalah 2 minus I, then dia punya conjugate pun akan exist bersama-sama, meaning that the other root will be 2 plus I. Okay, so indirectly kamu akan ada dua roots automatically, terus ada dua roots. So since polynomial kamu ini adalah power 3, so you know that there are 3 roots. 3 roots. Okay, satu roots adalah given, roots yang kedua adalah based on this definition, and the other one tu yang kamu kena cari. Okay, so how we find this? These two roots ini, okay, from these two roots, we can find a quadratic equation. Still remember SOR and POR? So quadratic equation x square minus sum of root x plus POR. Okay, you use this general equation from the last week punya lecture. So daripada sini, okay, so ini settleannya 2 plus I, then a quadratic expression can be made from the complex root given. Okay, so this is the general. So this is your first root, second root. Okay, addition, you get 4 because 2 plus 2, 4, I minus I 0. Then this one, product of roots, so be careful when you multiply I square, because I square equals to negative 1. So minus negative 1 is plus. So you get this. X square minus 4x plus 5. So from these two roots, you get a quadratic equation ini. X square minus 4x plus 5. So daripada sini, in order to find another linear factor coming from your polynomial, we do long division. 2x cubed minus 5x squared minus 2x plus 15 divide dengan ini, then you get this. Okay, so meaning that your px ini equals to, this is obtained from the complex zeros yang tadi tu, then another one is power 1. Okay, when you multiply these two, highest power 1 and highest power 2, so the polynomial you will get is 1 plus 2, you get a cubic. Alright, so the zeros are 2 minus I, 2 plus I, and negative 3 over 2. If they ask you to state the roots, then the roots are x equals to 2 minus I, x equals to 2 plus I, and x equals to negative 3 over 2. Okay. Okay, I think this one you can try by yourself. Given one of the root is 0, of the 0 are x cubed minus x squared plus 2 is 1 plus I. Since all the coefficients are integer, okay, so we know that the other zeros are 1 plus I. Okay, this one is given. So daripada these two complex zeros, you can have a quadratic equation. Quadratic equation using this formula, x squared minus SORX plus POR. Okay, this one. Alright, so this is cubic. You get a quadratic. Then when you do long division, x cubed minus x squared plus 2, this is a quadratic. Then you will get another linear here. Okay, so a quadratic expression can be made. Okay, then you get this. Then you do long division, and you find this linear factor. Okay, that is the example. Okay, but then if I change the question, okay, show that this 1 minus I is the zeros for this. So you must find the value P 1 minus I equals to 1 minus I cubed minus 1 minus I squared plus 2. You must expand this and show me that you get 0. This is when I change the question, show that is it 1 minus I is a 0 for this polynomial. Okay, more example in the next slide, and you can do your tutorial as well. So okay, I think that's all for this subtopic. So if you have any problem or you don't understand, you might ask me lah. You can WhatsApp or you can meet me in my room, right? Okay, that's all.